Guten Morgen, everybody. It's back to Organic Chem, Chapter 5, Alcohol. We have one of the more important chapters in Organic Chem, where alcohol will probably come up every single passage, and it will involve either a nucleophilic attack or some kind of reaction, and you will see the word OH, just like how your face will be going OH, O, all the time. Let me close my window. There we go. So, to look at alcohol, we have ethanol or ethyl alcohol because it's attached to the 2H or the 2 carbons. And if it's 3 carbons, then you know it's a propyl alcohol or a propanol. And if it's 4, it's butanol, and so forth. So just looking at the common nomenclature back in chapter 1. If it's attached to a benzene, a ring, aromatic ring, remember the rule 4 pi plus 2 electrons, then it's called a phenol. If it's 2 alcohol attachments, 2 hydroxide attachments, then there's an O in front of it. O, think about O next to it, and then if it's M, think about M. It's 2 strokes, right? O is a single stroke, so 1 away. M is 2 strokes, 1, 2, 2 away. P is all the way down, right? Right across because of that line. That's just a little thing in front of it. So if it's a 1, 1, 2, O phenol or M phenol or P phenol. All right, and it is a strong acid when there's alcohol attached due to the hydrogen bonds stabilizing. The slightly more positive hydrogen will bond to these electrons and make a low hydrogen bonds, as discussed in earlier chapters. These hydrogen bond interactions increases the boiling temperature, so you require more energy to boil and heat it up to break apart these bonds. And as a result, the stabilized conjugate base, when you lose this hydrogen, the electrons is conjugated all around, and it basically allows the base to be more stable, hence the acid is stronger. Now, if you think vice versa, if your acid is weaker, then your base is stronger. So you have a strong base. NaOH, for instance, is a strong base, so its conjugate acid is weak. All right. Then we have mesylate, tosylate groups make OH a better leaving group because OH by itself is more of an attacking group, right? In nucleophilic substitutions, in SN1, SN2 attacks, it's more of the nucleophile and attacks. Now, if we want to make it a leaving group instead, you add a mesylate, which is with a sulfate to it, or tosylate with a lot more carbons attached to it to make it big and stable at leaving the remaining group a more stable electrophile. Now, what we can also do is use alcohol to add to a ketone to make this protected group, because when you have adding reducing agents such as lithium aldehyde, lithium aluminum, these reducing agents, to add H to them, you might not want these to be reduced, these oxygen carbonyls to be reduced. So instead, you use the hydroxides and alcohols to put a little cap on it to prevent it from getting plucked. Now, to review and revise what the oxidation is, remember the more oxidized a compound is, the more attachment and bonds to oxygen is. So think about it. If you add both of these OH, you're not changing the oxidation state, right? There's still 2 bonds to the oxygen. Carbonyl has 2 bonds here to the oxygen. Using the alcohol cap, you're still having 2 bonds to oxygen. Whereas if you straight up add the lithium reducing agent, you're going to end up with a OH here, straight up. You're going to have 1 less bond to oxygen than before. Now, what's happening here? Well, if you add a phenol and add an oxidizing agent, you're going to end up with a kenone, because remember, if we were to reduce it, you might go from carbonyl to just an alcohol, but if we were to oxidize it using something called PCC or any other compounds that we'll discuss later that has oxygen in them, that's going to oxidize it, meaning more bonds to oxygen from one bond to two bonds to oxygen now into a kenone. You can also turn it from kenone, oxidize it more into a hydroxykenone, which add an additional hydroxy group to it. And furthermore, the final boss form is ubiquinone, where you can add a lot more oxidation state oxygens to it. More bonds to oxygen means more oxidized, and we'll talk more in chapter 6 what some of those redox agents will be. But in general, alcohol, just remember that they are strong acids, and because their base are strong, their base are stable because the acid is strong, and also they participate in a lot of reaction, especially the oxidizing, reducing part. We'll be discussing more in chapter 6.